After I released this video yesterday, it seems like Anthony Riley has some problems with the results because reasons. You can't use a linear scale to close to the horizon. For the same reason you can't use a sextant close to the horizon. It denies the perspective we criticize you a lot for ignoring. How can we do something you can't describe how works? If we should add perspective, we need to know how, where, how much, in what direction. All of that. You can't just say add perspective. Your definition of perspective might not be the same as my definition of perspective. My definition is objects get smaller at distance into a vanishing point. From the sides, from the bottom, from the top. Everything goes towards that point. Nothing goes towards that point and all of a sudden go down bottom first. That doesn't happen in my version of perspective. If it does in yours, please show us how, where, what distance, what size, everything, what angle. Good luck with that. Yeah. I have given you why your model is wrong. I know you don't understand it and I think I'm just saying it. Yeah, I think you're just saying it. It's difficult to describe in a text message what can be shown in two simple diagrams. You will get your chance later, Anthony. Don't worry. I got it all planned for you. Dear, oh dear. You've seen the convergence grid, haven't you? Yeah, as I said, everything goes towards the point of convergence. However, have you ever seen anything go from above eye level through the vanishing point of convergence and end up below eye level? Have you ever seen that? I have. Wait and see. So, next point, and this is lots of word salad. I'm not going to read all of it. You might do at your own risk, but I wouldn't recommend it. So I'm going to jump all of this word salad. I just don't care. He has something about the sextant and 15 degrees. That's all over the place. Just apply why a sextant doesn't work. Yeah. He had a link here, spam folder. Yeah, I can't find it in the spam either, but I saw the link. It was some star trails going down towards the horizon, and then it's a little bit of a little bit of distortion. Nothing much, nothing to change the shape of the Earth from globe to flat. Nothing magical, just some straight lines, and not so straight into the horizon. Just a little bit. And he has something here about we can't use real measurements. I'm going to find it here. If you don't understand the non-linear scale point, well, perspective is the way our eyes see. That's all. It's the opposite to orthographic view, how our eyes do not see. So, is that your definition? How our eyes see? Is that all? So how can we add perspective to our observations and models? Question mark. Again, the sextant. I'm just looking for where he said about numbers are not the standard of evidence. And again, the sextant. Always the sextant. A little bit of exploring the plane and coming back to him in a short while. And he asked me here to change my model. So I said my model is based on numbers, actual measurements. So give me what I need. And he says that's the problem. It is not based on actual phenomena. I've tried to tell you that. Yeah. You should accept the point I made. You have used absolute values to the heights. Yeah. Observer height, the height of the mountains. They are fixed, they are real, they are solid, they are physical objects. They don't change with distance. They're always there. You should have used, get ready for this, non-linear convergent scale sizes in accordance with the same rules for y sextant does not work below 15 degrees. Holy smoke, Batman, that's a mouthful. Try to say that fast 10 times. Non-linear convergent scale sizes in accordance with the same rules for why the sextant does not work below 15 degrees. Yeah, if you can show me the numbers for that, I will clearly just put it right into my model. No problem. Just show me how it's supposed to work. Wow. You can't believe your absolute values are correct if you want. Yeah, they're measured. And only the internet and you can believe anything you want. So I should believe your words here when you have nothing to show for. Isn't that believing the internet? Just asking. Yeah. Let's see what Exploring the Plane has to say, and yeah, this also will hurt. Where did it go? Here. You're making the same mistake again. When was the last time? I can't remember to have seen your name before. So, again, from when? Angular size is not perspective. Angular size gets smaller with distance. Perspective. How are you accounting for the loss due to angular resolution in your model? I'll show you in a small minute. Yeah, in a short time. It's more than just angular size reduction for a start. Your model needs to include convergence and compression to be realistic. It does. Wait and see. I'm confused. Does your model? Yes, it does. I just explained here. You're accounting for compression and loss of visibility due to language. Yes, I do. This is the whole point. Our eyes and cameras cannot resolve narrow angles at eye level. Have you gone to the school of Gary Oyabenga? So our cameras and eyes cannot resolve smaller objects at eye level. How about above or below? Does that make any difference? What if I tilt the camera? When will it resolve smaller angles? Just asking. And I'll show you in a short while how this works. Oh dear. The camera cannot resolve the bottom of objects at your eye line because reasons. So there is an inevitable drop of the whole object, which brings about a convergence to the vanishing point. No? Let me ask a question then. If the camera cannot resolve the bottom of objects due to angular resolution, then do you expect the upper part of the objects, the resolvable part, to hang in the air as though the bottom is resolved? Surely the whole object would shift downwards. What else can it do? What happens to objects when their bottoms are not resolvable? Do they hang in the air with no bottom, or do they converge to the eye line just like perspective says? If I cover up the bottom of anything, my camera standing on a tripod, if I cover the bottom of that tripod, I can still see the top. That doesn't go away. The height of that tripod and camera doesn't change. I don't see the bottom. It's still there. The top doesn't change because you can't see the bottom. It's a physical object. If you obscure the bottom, the top doesn't sink down. It's still there. Wow. But I'll give him this one. The entire physical object is still there, but optically we lost the bottom part. Optically, yeah, not physically. I'm asking then what happens to the top part? Optically, not physically. You say it doesn't hang in the air. I agree with you. Yeah, it doesn't hang in the air. And the top doesn't sink down. The top is still the top. I used the Eiffel Tower here as an example. And even if you can't see the top of, even if you can't see the bottom of that Eiffel Tower, it's still there, holding up the top. The top is still 300 meters high. So that follows the rules of perspective from a point 300 meters up, not something closer down, lower down, because you can't see the bottom. That doesn't drag down. That's not how it works. I suspect that I'm going to disagree with you, but I will watch it. Cool, thanks. So, let's go into some of these points. So, here's my observation. The lighthouse here can be seen as Blackpool Tower. The turbines can be the mountains. So, this is pretty much the same setup as that observation. This is the ocean. It should be flat. I hope we can agree on that one. If the Earth is flat, that will be flat. So, cameras cannot resolve smaller objects at eye level. My eye level is at 22 meters. It's just about at the white part on the lighthouse here. So, these cables are holding up that antenna. The top of the light here is about 47 meters above sea level. So if that one is, let's say, 25-30 meters high, those cables, I would claim that they're not much more than an inch thick. That's a decent size cable for just supporting an antenna. So at 4.5, 4.7 kilometers, my camera can resolve that cable 1 inch thick at eye level. You can see turbines behind there, here and here, at the same level. So if my camera can resolve that cable and those turbine blades at that distance, 4.5, 4.7 kilometers, those turbines are 68 kilometers away. So I think I should be able to see what they are standing on. So here's the orthographic drawing of my observation. I'm standing here, 22 meters above sea level. That lighthouse is just there to put my point of reference on, nothing more. It has nothing to do with actual observation. So, no matter the distance over a flat surface, I should be looking into a point 22 meters above sea level. If that's 100 meters or 68 kilometers over a flat surface, I should be looking into that point over there. The hill it's standing on is 175 meters high. So that should always be above my eye level. The hub height is 269 meters above sea level. That should always be above my eye level. Sorry. And the top of that turbine is 325 meters above sea level. that should most definitely always be above my eye level. So then you say, oh, what about reflection? Well, as long as this is a flat earth, flat surface, there will be the same level all over the place. Here's the gradient from the white part to the gray part. It gets denser with the thicker atmosphere, and the temperature should be about the same all over the place because it's flat. So there is no change over here. If there is any change, it will be due to weather. So at a distance of 68 kilometers, how much would this change for me to have the top of that below my eye level? Well, refraction depends on temperature, right? So, first time I was here, it was snow, it was cold. People are dressed pretty thick clothes. The turbines are below my eye level. Next time I was there, sea is still cold, but weather is warmer. Still below my eye level. Next time I was there, middle of summer, people are bathing. It's warm, the water is warm. The turbines are still below my eye level. And then I had a trip well wasted. 3 hours each way. That's how long I had to drive to get here. Last time I was here, in October, sorry, the water is warmer and the air is colder. Quite the opposite of earlier. Still, the turbines are below my eye level. And at no point whatsoever can I see that point, which I should be staring right into, at 22 meters above sea level. So you can count for perspective, refraction, conversion, compression, whatever. It just doesn't work. ABC, anything but curvature. Oh dear. So, let's see here. Here's my setup. That's my camera. This one. Canon EOS 7D Mark II with a Sigma 100 to 400 mm zoom. It's not a Nikon P900 or a P1000, but this lens costs as much as a P900. This body costs more than a P1000. So I'd say it's a real camera. It's not a toy and a real lens. And over here is my water level. So my line of sight is 22 meters above sea level. There's the water level, 1 meter 40 apart, 22 meters above sea level. So when I line up that camera, the horizon doesn't rise to eye level. The only way the horizon rises to eye level is this. That's it. So 22 meters above sea level at that lighthouse, it's there. So at what time should I not be seeing the bottom of that hill at my eye level? 22 meters at 68 kilometers. That should be just about on that line there. If these turbines are 325 meters above sea level, I should be looking up, not down. There's no laws of perspective or convergence or refraction or anything for this to happen. I should be having the bottom of that hill there, and everything else should be squished together if it was refraction. There's not that much of distortions going on. A little bit, yeah, but not enough to cover anything. And even if the bottom is not resolvable, it's still there. There's a hill there, 175-meter high hill. That should be resolvable. I can see the turbine blades at that distance. Seriously. So again, the orthographic view from my eye level to here, no matter the distance, I should be looking up. This not only goes towards the vanishing point, it crosses it and goes below. That shouldn't happen. That's not how perspective works. So if you want, I'll do this. I move the cursor. Please take a screenshot of this. Are you done? Okay. Here's the map. Please take a screenshot of this. And I will also have the coordinates for this in the description. So yeah, please do anything you like with it. Anything you need. I can go through the photos one more time so you can have everything. Just take screenshots all over the way, all over the place. This one. And yes, it's watermarked. This one. That one. And this one. Right. Do you have the screenshots? Cool. So, about my models, if they have all these conversions and compression and perspective. Let's just perspective, that's covered. Conversions and compression, well, let's go for a walk again. As you can see, there's clearly something here, because that tower is getting damn tall. Lowest mountain is now about to be higher than the blue and higher than the yellow. So yeah, I would say this works pretty well. How about conversions and stuff? Esk Pike. Let's put that eye in the middle of that P there. And zoom out. Everything converges and compresses into that point. Smaller it gets, yeah. And zoom back in. Still into the middle of that P. I think we've got that covered. So I say my molds work exactly as they should. Orthographic view is an excellent way to see how this works. Here you can draw lines from the observer via point of reference, which is Blackpool Tower, towards the mountains. So you can draw angles and whatever is hidden, and yeah, pretty much everything can be drawn here. And you can compare how it looks from flat to curved. So orthographic view is an excellent way to show how stuff works. And it's still reality. Just as the measurements of these mountains, every distance is correct, every height is correct, the Blackpool Tower is correct, with numbers, because we need numbers. Just as the same as the end of the world where I have my observation. This is the flat Earth, and this is not how it looks in my observation at all. because here the top of that turbine is higher than the top of that lighthouse. The grey part here is the hill we're standing on from the start of the shoreline. Let me see. Go back here. No, not that one. Here. There. So the grey part starts here at the shoreline and goes all the way up here. That's the grey part. So why can't I see that in my observation? This is just the island here. This is just this part. When the hill is here and my camera is not supposed to resolve that object, smaller objects, when the hill is 175 meters high and it goes all over the place, and I still can resolve that turbine when I can see the cables here at the same level as those turbines. Do you see now how that doesn't make any sense at all? Again, orthographic view is a great way to show how this works. The yellow part here is my line of sight. That's what I'm actually seeing. Everything else here is hidden. And the hill here is pretty damn big one. It goes all the way from here to here. It is 175 meters at the highest. At the globe Earth, this is what I see, and it makes a little bit more sense actually. So your ABC, nothing but curve. Yeah, this is curvature, and then matches perfectly what I see in my observation, where the wind turbine is below my eye level. Matches perfectly. Just add curvature. So the yellow part here is what I see. It's cut off by the horizon here, and that grey part is the hill. I don't see that. Matches perfectly. So again, point of convergence. If I'm standing here 22 meters, that's my eye level. Everything above me should converge on those lines, and they should continue upwards in those lines. Everything above me should go above me. At a distance here, again, my eye level is 22 meters, that line there. So everything above me here should converge above me on the flat surface. Those lines of convergence here goes upwards always. So when looking at the top of those turbines up here, that square, the top is, this is 100 by 100, so that's 300. The top of the turbines is even higher. That should converge upwards, not down as I see in my observation. And again, the orthographic view is a great tool to show exactly what's going on. Here you can have all the lines of sight and what's hidden and everything. So orthographic represents reality pretty damn well. Perspective, orthographic. No magic involved whatsoever. So how about how about we end with this? All the images I've shown here, take a screenshot of whatever you like. The distance, the observer height, the target height, everything is measured and accounted for. I'll leave the coordinates in the description. Use whatever you like, pen and paper, computer, anything. Show how this is supposed to work on a flat earth. If you know who Gary Waibenga is, you probably do. He had 2 years now to show me wrong. He said 2 years ago he would do it. It's a simple drawing. I did it in 10 seconds. I just draw simple 4 lines to show how it works. Gary had 2 years. Still can't do it. So, yeah, use anything you like. Be my guest. Show me wrong. Good luck, and thank you for watching. Bye bye.